Good morning, my dear students. In today's class, we're going to get started to work deeper into the atomic structure. So into the atomic module, we know how to represent the nucleus and the levels of energy. If you want to understand in a better way that part, you must remember that the levels of energy are just representations of how the electrons are moving around the atom. If this is the nucleus of the atom and stuff, right? Around it are going to be the electrons in an electron cloud. So we use electron levels of energy for explaining that. Now, you must take into consideration that those levels of energy or orbits that cover the nucleus also contain some levels of energy which try to determine the path of electrons. Also, you must take into consideration that the electrons are always in pairs because one charge repels the other one, and as a consequence, they continue to rotate. Okay? Being said that, let's continue to the inner parts of the levels of energy, which are the sublevels of energy or orbitals. For explaining that, I wanted to take into account this. And this part for the class for today is just for you to remember that the sublevel of energy S, P, D, and F, all of them are going to be found into the levels of energy, into the orbits. That's why we call them orbitals. So each sublevel of energy has a specific characteristics. So for example, something which is really interesting to mention that the S, for example, contains 2 electrons, right? The S, and the name for the S is called sphere, right? The sphere has a shape, as it says, of a sphere covering the nucleus, a sphere covering the nucleus into the first level, a sphere in the second level of energy, a sphere in the third level. So all of the levels of energy contain a sublevel which is called the sphere, and that the sphere can be only filled with 2 electrons. Well, let's talk about the sublevel P. The sublevel of energy P contains or can contain only 6 electrons. Well, 6. In total, 3 pairs of electrons. Remember what I said, the electrons in pairs? So 3 pairs of electrons rotating in 3 different ways. What is the meaning for that? If you think about the number 8, the electrons move this way in X, making an 8, right? But in 3 dimensions. I'm explaining 2 dimensions at this moment. I want to show you in a graphic. And in Y and in Z. See? 3 pairs, 2 in X, 2 in Y, and 2 in Z. That's a little bit to explain the P. P means principal. Now, the D is the diffuse, and it contains 10 electrons in total, 5 pairs of electrons. That's a little bit difficult to explain. I want to show you a graphic later on. And F means fundamental, which is the most difficult to explain in this way, but it contains 14 electrons, and that means 7 pairs of electrons. If you understand that part, you can see that all of these sublevels found there are the orbitals into an orbit and stuff. Let's see let's continue with the next part. Being said that, S for sphere, P for principal, D for diffuse, F for fundamental. Let's go to the next part. For observing this, I have planned these other parts, which is this mentioned in this sublevels. So for explaining and understand this in a better way, you can see that the first one, for example, this sublevel of energy, which is the sphere, as I showed you before, right? A sphere containing, so inside is going to be the nucleus always if the sublevel belongs to the first level, and then the sublevel P, Px, Py, Pz. You're going to call it P in X, P in Y, and P in Z, right? In the 3 dimensions, and pay attention to the Ds. These are going to be called D1, D2, D3, D4, and D5 for understanding just that in a better way, that 5 pairs of electrons are going to be rotating. 2 in the first D1, 2 in D2, 2 in D3, 2 in D4, and 2 in D5. What's the meaning for that? In total, 10 electrons rotating all of those paths, and the same thing for F14. In each of these shapes, you can see that are difficult to explain, but they show 3 dimensions. 2 pairs in here, 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 and 2 pairs in here, so on and so on. So in total, 14 electrons for the sublevel F. If you understand it, let's continue. Otherwise, pause the video and watch the explanation again. Being said that, now we're going to do an exercise using that. For explaining that part, I want you to pay attention to this part. We're going to work specifically sharing a way of constructing the atomic module. Some of you guys, because you're really smart, you told me that the most accurate module for explaining or understanding the atom is using Bohr's module. And yes, so we're going to do some, we're going to add some extra information we have nowadays to the Bohr's module for constructing new ones for understanding in the most accurate way, or the most accurate and possible way for understanding the behavior of any atom. Why is that? We need to understand how atoms behave so we can predict the chemical properties, and as a consequence, predicting the chemical reactions, which is going to come into next year for Prep B. Being said that, let's continue with an example. I have selected an example for working, and today we're going to construct gallium. If I wanted to design the atomic structure for gallium, I want to ask you to do the following. You're going to design the nucleus, right? The nucleus for gallium, and to draw it that size. This one, let's pretend this is the nucleus for gallium, that big. If it that's why we decided to construct a module, and we're going to separate that. In the first part, if you pay attention, or if you visit the periodic table, you're going to see that gallium has a specific number of 31. If the atomic number is 31, that means the number of protons is 31 in total. 31 protons, okay? Instead that, if you pay attention to the same periodic table I gave you, you're going to find that it has also a mass, and a specific mass of, if you can round it, it says in your periodic table that the mass of gallium is 69 and 0.7. You can round it to 70. 70 minus 31 is going to give you specifically 39 neutrons, right? Okay, so being said that, let's get started to draw now the levels of energy. For the levels of energy, if you visit in which row gallium is located, it is in the 4th. So we need to draw 4 circles, or 4 orbits, or 4 shells. In order to draw it in a better way, I'm just going to draw a small portion of the shell because I don't need the rest, okay? So what I'm saying is that I'm just going to draw something like this, and I am going to cut part of the shell, and I'm going to draw just a small portion of it, okay? Yeah, something like this. I'm going to use this one. I'm going to move it there, specifically there, and I'm going to put another one, 2, right? And then 3 levels of energy, and then 4 levels of energy. Being said that, if you have that, now respecting the structure for Mr. Bohr, he didn't call the levels of energy with numbers. He preferred to use letters. So let's talk about it. He said the first one is called K, and the second one he said is L, the third one was called M, and so on, right? So we're going to respect his module so he doesn't kill us and stuff. So, okay, good. K, L, M, N, and then how to feel. We know that each level of energy contains some specific electrons and stuff. And according to notes and stuff, if you want to know how many electrons specifically are going to be in each level of energy, then you need to pay attention to the following. I wanted to use the following for your classes. It's going to be attached in the video also, this chartcito, I call it, this chart for labeling or naming electrons. So we're going to use this chart for filling electrons. This is a map for filling electrons. So I wanted to have it into your notebook. You can paste it in the back of your periodic table and stuff, because we're going to use that map all of the time until you know how the atoms are constructed. So pay attention to the arrows in this moment. If you think about this, look at this. It says the first level of energy is 1s, 1 sphere. It says moves this way, and you follow the arrow, just follow the arrow, and then you go to the 2s. What is the meaning of the 2s? Then you're going to put this one. The first s that means for the first level of energy, or for the level K, right? Okay. and this one is for the level L, and this is for the level M, or the third level of energy, and this is for the level N, or the fourth level of energy, and this is for the level O, or the fifth level of energy, and so on, so on, so on, so on, so on, okay? And so being said that, if you got that part, this is the first level of energy, right? This corresponds to the first level of energy. This one's for the second, this one's for the third, this one's for the fourth level of energy, this one's for the fifth, the sixth, and the seventh. For our case, what we have to do is just get it to work. Now, let's see. Being said that, let's start filling electrons, okay? What are we going to do? We just have to write under each sublevel of energy this way. So you have the first level of energy. It says, okay, get started to fill, that is the meaning for that. Get started to fill the first level of energy. In here, we are there. Okay, we are in level K, the first level of energy, and it says there, fill the first sublevel S. So what are we going to do that? We go there, we are there, and you put specifically, it says 1S, right? 1S, and that's it, 1S. But how many electrons for the S? 1s2, okay? Because as we studied, this two level S fills with 2 electrons. So we're supposed to do this step or this process for filling 31 electrons, because the atomic number is 31, or 31 protons, right? So 1s2. And then it says, once you're done with the first S, it says go to the 2s. It says go to 2s. Oh, so the first level of energy is done. It says now move immediately, follow the arrow to the second level of energy. Let's go to the second level of energy, and you follow the arrow, it says 2s. Oh, then you have to write in here, go to the second level and energy and write 2s, 2s2, 2s2, 2s with 2 electrons there. Once it's done that part, and then it says 2s2, and then follow the arrow, and then it doesn't say go to the third, you're staying in the second level, and now it says fill the 2p6. Oh, 2p. Why p6? Because p with 6 electrons, as we studied before. 2p with 6 electrons. So you put p and 6 electrons. Keep counting. So far, we have completed 2 plus 2, 4 electrons plus 6, 10 electrons. From the 31, we still need to complete, right? We have 10 electrons, we need 21 more, okay? Let's continue. Follow the arrow. We were in 2p, and then it says move immediately through 3s. What is the third level of energy? 3s. So then you copy the third level of energy. Again, 3s. As we know, the sublevel S fills with 2 electrons. You put 2 electrons there, and then follow the arrow, and then it says go to 3p. So we're in the third, still in the third, but now with p, 3p. And the p, exactly as we studied before, is filled with 6 electrons, okay? And let's do the addition. We have 10, now we have 18. So we have to do this until the 31 finishes. Let's continue. Then we have the 3p, and then continue the arrow, and it says move not to the 3D. It says, you follow the arrow, move to the 4s. Oh, let's go to 4s. 4 level of energy. Go to the 4, and you write 4s, right? And the S is filled, as we studied before, with 2 electrons in the last level of energy for the 4s, and continue for 4s, and then follow the arrow, and then you go back, and it says go back to 3D. Okay, not the 4, but it says 3. So 3, go back to the third or the previous level of energy, and it says 3D. And here, 3D. Okay, and we know that the D's completed their field with exactly 10 electrons. Let's count so far. We have 2 plus 2, 4, plus 6, 10, plus 12, plus 2, 12, 18, 28, plus 2, 30. But it says 31. Oh, then after filling the 3D, right, it says go where? Oh, to the 4p. And then you fill the 4p. And here comes the magic, because it says 4p. We know the p is filled with 6 electrons, but we're not going to put 6, because we don't need 6 electrons to complete the 31. We only need 1 electron. So you are going to put in here 4p 1. And that is going to be the structure. Guys, as a consequence for this, then you know how many electrons in each level. Now we know that in here, in the first level of energy, you have 2 electrons. Now you know that in the second level of energy, you have 8 electrons. Now you know that in the third level of energy for gallium, you have specifically 18 electrons. And now you know that in the fourth level of energy, you have 2 and 1, 3 electrons, you see? So this is the real method or module for understanding how many electrons in each level of energy according to this map I just gave you. This map I just gave you comes from the process which is called quantum mechanics, right? Or the quantum module for understanding the structure for the atom. Now, as I said before, this is the structure for gallium, okay? So if you pay attention to the periodic table, gallium is telling you all of this information. Gallium is telling you it has 31 protons. Gallium is telling you it has 39 neutrons because you subtract the mass minus the atomic number. Gallium is telling you that if it has 31 protons, it has 31 electrons. And all of those electrons have to be distributed in this way, okay? So the periodic table is telling you that gallium in the last level of energy contains 3 electrons because it is in the column that says 3A in Roman numbers, or column 13. And also the levels of energy in here, which is basic. And now we know a little bit more that each level contains sublevels, and those sublevels contains the electrons distributed in this way. Remember, all of the electrons go in pairs and stuff. So for representing that way and for finishing this exercise for today's class, we're going to do this representation of how each electron is moving, right? Or how the electrons are moving into the sublevels of energy. How are you going to do so? You put here this. I'm going to write. The first level of energy is called K, right? According to Mr. Bohr. So then you're going to do the following. The first level of energy says it is 1s2, right? 1s2. So how do you represent that? How are you going to represent that? So you're going to put that specifically that this way. You're going to draw a line there, and into the line, you're going to represent small arrows, okay? Small arrows, okay? One arrow this way, and one arrow this way, because it says 2 electrons. Those arrows represent that the electrons, first of all, there are 2 electrons, and both of them are moving in different directions, or so, because they're repelling. They can't be moving in the same direction because otherwise they're going to meet each other and so on. So no, the 2 arrows represent a repel, okay? That's why, that's just each arrow is 1 electron. And then the same exercise. We do the same thing, okay? Go there, and we do the same thing with a second level of energy. L, put there, the same process, right? You do there, it says 2s2. That's what it says. You just copy what you just designed. It says 2s2. And then the same thing. 2s2, you're going to do the following, right? You just do the same thing. I'm going to recopy this. I don't need to draw it again. And I put it there. There. 2s2. And the same thing you're going to do with arrows, okay? If you remember that, arrows. That means 1, and it means 2. Done. But also it says it has, right? Also it says it has 2p6. Since I told you that the electrons move in pairs, p6 means 3 pairs of electrons, so you will need to draw, right? You will need to do the following. 1. This is the line for the px. I'm going to explain, so do not cry. And this, and this one. Okay. Let's erase this. Yeah, okay. Now, being said that, so it says P6. What's the meaning for P6? Oh, there are 3 types of P's because P6 are 3 pairs. So you're going to put this way. You're going to put, first of all, it is 2px, right? 2py, and 2pz. Okay, so and each one with 2 electrons, 2 electrons, 2 electrons, in total 6, and each one the same process, 2 arrows, right? 2 arrows, 1 arrow there, 1 arrow there, 1 arrow there. Wait, sorry, you don't feel the arrow. It says P6, you feel it always the ones in one direction, and once you're done in one direction, you go to the direction. So P1, in total 6 electrons, 1, 2, 3, and then 4, 5, and 6. Understanding this, my dears, is the foundation of chemistry. Okay, so being said that, let's continue. Now, the same thing you're going to do for the third level, M. Okay, M, and so on, and you put there. It says the same thing, right? It says 2s2, 2s2, right? The same thing. It says 2s2. Then the same thing, you put 2px. It says 2py because it's not, sorry, it was 3. Yes, 3px. It's 3s2, the same thing. And then also 3p6 and so on, 3py, 3pz, and also it tells you something even more interesting because it says 3d10. D10 is 5 pairs of electrons, so you're going to put the same thing as I told you before. 3d1, the first pair, 3d2, the second pair, 3d3, the third pair, right? 3d4, the fourth pair, and 3d5, and so on. And guess what? Each one with 2 electrons. Each one with 2 electrons. S with 2 electrons, P, all of the Px with 2 electrons, Py with 2 electrons, Pz with 2 electrons, and because that's the way, or the only way you obtain a 6 in total for P. 3D with also with 2 electrons, 2 electrons, 2 electrons, 2 electrons, and so on, 2 electrons. That way, guys, that way you contain 10 electrons for D. And the same process you're going to work there, and we just pass it there to another one. Draw again some lines, and then you recopy those lines and stuff, and then you're ready. Okay, I'm just copying that from another PowerPoint. I already have this. Okay, I'm going to paste that there, so you see the arrows for P6 and so on, and the arrows for there, for D1, D2, D3, D4, D5, and so on, and I will continue finishing that one. Remember, the way you feel the electrons and stuff is going to be always that really interesting way, but have in mind that you must continue, or you must feel the electrons in one direction, right? And then the other direction. At this moment, for questions of time, I'm just going to feeling it this way. But basically, you're supposed to do the process one by one since you're working by hand and stuff. For finishing into the last one, you're going to work in here. It says 4, and this one I want to do it manually. So let's work. Look at this. The last one is N. N. You're going to work this way. And N, it says the same thing. N is the 4th level of energy. You're going to put, so you're going to put 4 S, and of course with 2 electrons, right? And then you have that. You draw again a line, and then you represent it with arrows. So 1 electron and 2 electrons. Good. And also it says that you have a 4p1, and here comes the magic, because we know the p fills with 6 electrons, so you're supposed to put the following: 4px, because it's 3 pairs, 4py, and 4pz, and you have to draw the lines here. That you most have to draw the lines. So you draw this way, 1, 2, and 3 lines. And the P I have, how many electrons does it say to fill? It only says 1 electron, so you just draw 1 arrow pointing to the upper part. Now, these empty spaces, as I told you before, those are the implications or the amazing implications for chemistry. This is the foundation for chemistry, because knowing this, you know how the electrons behave. And as a consequence, you can predict chemical reactions for the future. Being said that, my dears, until here, I want you to have that, take your notes and stuff, pause the video, watch it again and stuff, okay? So that was it. That is until this spot, we have finished an attachment, that you could say, just an improvement of the Bohr's module or whatever it is, for understanding this in a better way. Being said that, so in our next class, we're going to do an extra thing because we need to add something else more, but we are going to finish for today's class until there. Being said that, my dears, so that was it. I hope you took your notes and stuff. Love you, kids.